In the last video, we set up a reference table that is going to allow us to solve problems using the heat equations. And so let's take a look at some sample problems now and see how I can use the reference table to help me solve the problems. All right, so my first problem here is how many joules of heat are absorbed when 50.0 grams of water are heated from 30.2 to 58.6 degrees Celsius. And they want us to express our answer in scientific notation. All right, so there's a little bit of work there. But the first thing we need to do is we need to look at our reference table and think, which one of these equations are we going to talk about? Well, our water is staying water, so we're not talking about the heat of fusion or the heat of vaporization. So we're going to use the main equation here. So Q is equal to mc delta T. All right, and so now we're going to fill in the numbers that we know into this equation. Okay, what do we know here? Well, we know that we've got 50 grams of water, so that is the mass of the water. This time, for just this first problem, I'm going to put in the units because it's kind of fun to see how the units kind of work out with these equations. Big C, this is a constant. For liquid water, the specific heat capacity is 4.18 joules per gram Kelvin. 4.18 joules per gram Kelvin. And delta T is the change in temperature. So how can we calculate the change in temperature? Well, the original temperature of the water is 30.2 degrees Celsius, and the ending temperature is 58.6 degrees Celsius. So delta T is equal to 58.6 minus 30.2. 58.6 minus 30.2. All right, and so that is 28.4 degrees Celsius, which is really the same as 28.4 Kelvin. Because Kelvin and Celsius have the same scale between a degree is the same amount of temperature change, whether you're measuring in Celsius or Kelvin. The only difference is what does 0 represent. So in Celsius, 0 is the freezing point of water. In Kelvin, 0 is absolute 0. All right, so we know delta T is 28.4 Kelvin. And Q, the heat, is what they want us to figure out. They want us to figure out how many joules of heat. Okay, so all we need to do is to solve that equation. So we've got 28.4 times 4.18 times 50. All right, and so we've got 5935.6. 5935.6. And notice what happens with our units. So I've got a gram here in the numerator and a gram in the denominator. So those grams cancel each other out. I've got a Kelvin in the numerator and a Kelvin in the denominator. They cancel out. And so the only unit that's left is the joules, just like I would expect my heat to be measured in joules. Okay, so there are two things we need to do left to answer the question. They want us to express our answer in scientific notation. All right, so the first thing we need to do is we need to think about how many digits of precision we have. So each one of these numbers that we're given has 3 digits of precision. So I'm going to write this as 5.9, and then I'm going to round up to 4 because 3.5 is closer to 4 than it is to 3. And now, how many places did I move the decimal point? I moved it 1, 2, 3 places to the right. So the amount of heat that is absorbed by this water is 5.94 times 10 to the third joules. Okay, so we did a couple things in that problem. We used the heat equation, and we had to remind ourselves a little bit about scientific notation and digits of precision. So all of that put together just got us to the end of that question. In the next video, we'll take a look at problem number 2.